The selection sort algorithm is based on the idea of finding the minimum or maximum element in an unsorted array and then putting it in its right position in a sorted array. It basically repetitively picks up the smallest element from the list and puts it into its rightful position. Now let us take a look at the working of selection sort with the help of an example. Selection sort divides the array into two parts. A portion of the array that contains the already sorted elements and the portion of the array which contains the unsorted elements. At the beginning, none of the elements are sorted, everything is in the unsorted part of the array. Selection sort begins by picking the smallest element in the list and putting it into the sorted part of the array. Initially, all the elements are in the unsorted part of the array. It begins by scanning over the elements of the array and finding the minimal element. 12 is the minimal element over here. Once it finds the minimal element, it puts it to the rightful position. If 12 is the smallest element, its rightful position is in the first position of the array. So the next step is to swap these two values. 12 is moved to its rightful position, and so this is the sorted part and this is the unsorted part of the array. Once again we go forward to find the next smallest element in the list. 20 is the next smallest element. Now 20 has to be moved to its rightful position. So we swap 20 with 50. Similarly, we go on checking for the smallest element and we go on adding it to the sorted part of the array. The next smallest element is 34. 34 is swapped to its rightful position. Then we have 50 as the next smallest element. Even 50 has to be swapped to its rightful position. With this, we complete sorting the entire array. This is how selection sort works. It repeatedly searches for the smallest element and it puts it to its rightful position in the array. Now let us have a look at a C program code to perform selection sort. In an example with an array of 5 elements, we had to perform 4 passes on the array to get the final sorted list. So for an array of size n, we will have to perform n minus 1 passes over the array, and in each pass we are going to determine the smallest element of the list. The I loop represents the n minus 1 passes, and inside the I loop we are going to set the first element as the min element, and we are going to compare this minimum element with every other element in the list. This comparison is done using the j loop. So here j starts from I plus 1. We are going to compare the minimum element starting from the next element in the list. This is the ith element and this is I plus 1. So j spans from I plus 1 till the end of the list. We are going to compare each and every element after I till the end of the list. And if we ever find an index j whose value is less than the value of minimum, we set that as the minimum index. Once we end scanning the entire list of elements, we will have the index of the minimum element. The last step is to swap the element at the min index with the ith index. This is what happens at the end of each iteration or each pass of the selection sort procedure, and therefore giving us this effect. This is how selection sort works.